So myself, Dr. K. Viswanath Allamraju, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In this session, we are going to study the path of contact, arc of contact and contact ratios through solving the problems. Now, let us recapitulate. The path of contact is the sum of path of approach and path of recess. So, from the formula, we can see here, path of approach equal to under square root of RA square minus R square cos square phi minus R sin phi. These letters related to gear. And this path of recess equal to small letters, that is R under square root of RA square minus R square cos square phi minus R sin phi. These letters are indicated to pinion. So we can interpret that path of approach is related to gear and path of recess is related to pinion. That means approach takes place. This approach takes place, engagement, beginning of engagement takes place. The distance from, what is approach means? The distance from beginning of engagement to the pitch point is known as approach. And the distance from pitch point to end of engagement is known as recess. This end of engagement, pitch point end of engagement takes place on pinion, and beginning of engagement to pitch point, that approach takes place on gear. That means this arc of contact equal to, it is related to this, again arc of contact. That arc of contact is related to the path of contact. That path of contact is related to beginning of engagement and the end of engagement. So this arc of contact, as I mentioned here, path of contact by cos phi, we can also write here RA square minus R square cos square phi minus R sin phi plus RA square minus R square cos square phi minus R sin phi by cos phi. That is RA square minus R square cos square phi minus R sin phi by cos phi plus small RA square minus small R square cos square phi minus small R sin phi by cos phi. So after knowing the substitution, that means this RA square minus R square cos square phi, the minus R sin phi, this portion is known as arc of approach. This portion is known as arc of recess. So now arc of contact is the sum of arc of approach and arc of recess. So now arc of approach we considered here for the gear and arc of recess considered for the pinion. Then it is known as the sum of arc of contact, the total arc of contact. So let us solve some of the problems based on this. This is the model number 3. Two involute gears are in a mesh have a module of 8 millimeters and a pressure angle of 20 degrees. The larger gear has 57 teeth and the pinion has 23 teeth. If the addenda on pinion and gear wheels are equal to one module, addenda A and pinion P, A and gear and pinion P, okay, P equal to one module. That equal to one module means 8 millimeter. What is the addenda? RA minus R, that equal to 8 and small a minus small r that equal to 8 millimeters. That is the meaning of here addenda. Addenda means distance between radial length, the difference of radial length of addendum radius minus difference means addendum radius and pitch circle radius. Similarly, for pinion, Ra minus R, and for gear, capital Ra minus capital R. Now find, there are three objectives, three main objectives. In the third main objective, there are three sub-objectives are there. Total 3 plus 2, 5 objectives we have to solve by using the given data. So what is the contact ratio? Contact ratio equal to arc of contact by circular pitch. That is the contact ratio. The exact meaning of contact ratio means the number of pairs of teeth are in contact. The number of pairs of teeth are in contact. Now, another objective is that the second objective is angle of action of the pinion and the gear wheel. There are two again objectives. Angle of action of the pinion. What is the angle of action? The angle of action equal to angle of action equal to arc of contact. For pinion it is smaller, for gear capital R, arc of contact by capital R. That is the angle of action. Next, third objective is ratio of the sliding to rolling velocity at the beginning of contact and at pitch point and at the end of contact. Now here we can directly answer this objective directly. At pitch point is the point where pure contact takes place, neither rolling nor sliding. That means the ratio of sliding to rolling velocity is how much? 0. Here you can tell directly this objective. So let us solve. Contact ratio begin. So phi equal to 20 degrees and capital T 57, small t 23, m equal to 8 millimeters, addendum that equal to 8 millimeters. How to solve? We need contact ratio. So what is the data required? First, contact ratio equal to arc of contact by circular pitch. Then arc of contact equal to path of contact by cos phi. Now path of contact equal to path of approach plus path of recess. That is Ra square minus R square cos square phi minus R sin phi plus small Ra square minus small R square cos square phi minus small r sin phi. So we need, if we want to solve contact ratio, it is connected to, we know the circular pitch, that is pi d by t. Okay, we can solve what is the pitch circle diameter and all. PC we required. What is PC equal to pi d by t? How pitch circle diameter comes? Then only number of teeth. We know the number of teeth. We have to find out pitch circle radius. Now here, in order to approach, what is the cos phi? Phi is the pressure angle, so cos phi known. And path of contact, we need the values of capital RA and capital R, small ra and small r. So are required. So how to solve? Capital RA comes from pitch circle radius plus module. That module is given here. Addenda on pinion and gear. RA can be calculated from this condition. and small r, capital R equal to m into capital T by 2. From this, we can find out capital R, small r, m into small t by 2. We know capital T and small t, the number of teeth on gear and the number of teeth on pinion. M times, what is that? M is here module 8 millimeters. What is capital T? 57 by 2. We know R. So these values we have to calculate. That is the main approaching the solving the problem. So whenever objective asked, we have to substitute the formula. We have to write down the formula. What are the known values and what are the unknown values? How to calculate those unknown values from the known values. So here the known values in this path of contact is 5. That's it. And what are the unknown values? RA and R. RA and R, how it comes from the known values? That is MT by 2, M into capital T by 2, M into small t by 2. Thus, we can find out the unknown values from the given data and based on the formula. According to the data, we have to use formula. Now, that's what we have done. Why we are solving capital R, small r A? That is the requirement for us. In order to solve the objective, crack the objective of contact ratio. That contact ratio involves arc of contact and circular pitch. And again, coming back to arc of contact involves the path of contact and pressure angle. And path of contact involves the radius of addendum circle, and pitch circle radii of both pinion and gear wheels, and also pressure angle. Now we know the known value pressure angle directly we know, but remaining also known but indirectly. So indirectly how to solve those RA and R, that is addendum circle radii of both gear and pinion can be calculated by using the data from the data, that is module values and the number of teeth. That's why we have started doing this R. Capital R equal to M into capital T by 2. That is 8. M is the known value 8. Capital T 57 teeth by 2. That is 228 millimeter. RA, that RA equal to capital R plus M. Capital R is 228 plus M module 236 millimeter. Alright. Now similar manner we have to apply the same methodology to calculate small r and small ra. R radius, pitch circle radius and addendum circle radius of pinion. Small r equal to M into T by 2, 8 into 23 by 2, 92 millimeter. That RA equal to R plus M, 92 plus 8, that is 100 millimeters. Now we know R, RA, similarly small letter, small r, pitch circle and addendum circle radius of both pinion and gears are known. Now, contact ratio equal to N equal arc of contact by circular pitch. Now, path of contact by cos phi, that is times 1 by pi m. Circular pitch means another pi d by t r, pi times module. Substitute over here RA square minus R square cos square phi minus R sin phi. Then the values RA we know 236, capital R pitch circle diameter, pitch circle radius of gear, that is 228, phi is 20. Substitute. Similarly, small RA and small letters R. So 1.68. The contact ratio is, how many teeth are in contact? One full teeth in contact, another one is 68%. So that is called 1.68 meaning. That is the contact ratio procedure. Substitute directly. That means they completely put the formula, get the answer. That's it. Next, angle of action. But that putting the formula, we need concept. Now, angle of action of the pinion and the gear. Second objective. So, angle of action on the pinion, that equal to arc of contact by pitch circle radius of pinion. This arc of contact, what is that arc of contact? The arc of contact by m, that is arc of contact equal to 40.31, 42.31. This pi m they did not multiply it last. So this is 42.31 is the arc of contact. Still, if you want to know from this what is the path of contact, this is the portion path of contact. Okay, that is 20.97 plus 18.79 path of contact. Now, substitute over here. We got it, angle of action equal to 26.3 degrees. 0.46 radians convert into degrees. 0.46 into 180 by pi. It converts 20. But from this angle of action comes in terms of radians. 0.46 radians. Now for angle of action on the gear. Angle of action on the gear equal to arc of contact by pitch circle radius of gear. That arc of contact we know 42.31 pitch circle radius. That is, what is the pitch circle radius? Capital R, 228. That is 228. Then it is 0.4856, 0.1856 radians. 0.1856 radians convert into degrees. This 0.1856 into 180 by pi. That is 10.63 degrees. The angle of action for the pinion delta P equal to 26.3 degrees. For the gear equal to 10.63. The pinion angle of action is greater than the gear. Why? Because the radius of the pitch circle, radius of the pinion is, pitch circle radius of the pinion is smaller than the gear. So when smaller person in touch with the larger person, then what happens? Smaller fist with the larger fist. The smaller fist angle of the contact is more in comparison to larger fist. Similarly, here delta P is larger in comparison to delta G. Okay, that means delta P pitch circle radius is smaller. That's why angle of action is more on pinion than the gear. For the same speed of contact, for the same speed of rotation, the pinion affects more because the angle of action is more than the gear. That's why pinion revolves number of revolutions in comparison to the gear. When gear depends upon the number of teeth. Here, the gear ratio G equal to capital T by small t. What is capital T? That is 57 by here 23. That means it is 2 times more. Okay, it is 2 times more. That means the pinion rotates more than 2 times than one single rotation of gear wheel, larger wheel. So it takes 1 revolution. The pinion takes more than 2 revolutions. That's why gear ratio here it is more than 2. G is greater than 2 times. Here, gear ratio. If the gear ratio is 3 means, that means the number of teeth on the pinion is 3 times lower than the gear, or the number of teeth on the larger wheel is 3 times more than the pinion teeth. Suppose if number of teeth on the gear is 300 and on the pinion is 100, then the gear ratio equal to 3. What is the meaning of gear ratio equal to 3? 3 times 1 revolution of the gear makes to rotate 3 times pinion. That is another meaning, physical significance of gear ratio. That is called. Now, in the third objective, we want a ratio of sliding to rolling velocity at the beginning of contact. At the beginning of contact. At the beginning of contact. There is a ratio. What is that now here? What is sliding velocity formula? Omega plus omega g times path of approach. That is for the beginning of contact. What is pitch line velocity? Pitch line velocity Vp equal to omega r times omega r. We want pitch R. Okay, omega P times into R. What is the R is here? Path of approach. Rolling velocity at the beginning of contact. The rolling velocity, that is omega P times radius of the pitch circle, pinion. Omega P times 2. Now here we know what is the omega P. So if you substitute here, this omega P can't be known, but it will be cancelled here. That is the angular velocity of pitch point. That is the angular velocity of path of approach plus pinion. So this angular velocity of pinion, how to calculate? Let me think. Number of 2 pi omega P equal to 2 pi np by 60. So we don't know the speed, because here it depends on number of teeth the data given. But somehow what will happen here, omega P will be cancelled. Then it is 0.32. Next, at a pitch point, this is 0, because neither sliding nor rolling. No sliding and nor rolling, it is 0. The third objective is that path of recess. So sliding velocity and rolling velocity at the path of end of contact, that is called path of recess. This end of contact takes place, that is another means that end of engagement. End of engagement means, that is end of engagement, that is called path of recess. That is omega P plus omega G times path of recess by omega P times R. Now again, this 1 plus this omega P make it cancel, then finally it becomes 0.287. So at the beginning of contact, ratio is 0.32. 0 point beginning, at the beginning of contact, it is 0.32. At pitch point, it is 0. End of contact, that is 0.287. So the ratio is more sliding to rolling velocity at the beginning of contact is more than the pitch point and end of contact, or larger value. Why beginning of contact the sliding velocity rolling velocity ratio is high? Because the length, contact length, is the path of approach is more than the path of recess. That's why here the sliding to rolling, that's why here it is this sliding to rolling velocity is dependent upon path of approach and path of recess. So the path of approach value is more than the path of recess. That means the contact length during path of approach is larger than path of recess contact length. That's why here in this case the beginning of contact sliding velocity to rolling velocity ratio, that is 0.32, is higher than end of contact, that is 0.287. So that is the meaning. These are the how many objectives we solved here. First objective 1, second objectives there are 2, that is angle of action, the pinion gear. There are 6 objectives calculated here, we observed. So if we know the parameters of the gears, such as module value, pressure angle, the number of teeth of pinion, number of teeth of the gear, if we know, and also condition that the end of pinion and gears are equal to one module, then we can solve the contact ratio, the angle of action, and the ratio of sliding to rolling during beginning of contact, at pitch point, and end of contact or end of engagement. So these are the objectives can be calculated provided if we know the number of teeth of the gear and the number of teeth on the pinion and the value of pressure angle and module value. Then we can solve. We can solve objectives of contact ratio, angle of action, and ratio of the sliding to rolling velocities. Okay, next. The next model is that In this model, we are going to study velocity of the sliding when the contact is at the tip of the tooth gear, and also we'll find out maximum sliding velocity, maximum velocity during sliding. So what is the data is given here? There are two, that is pressure angle equal to here 20 degrees. Have a module pitch of 4 millimeter. Okay, module pitch, the number of teeth on gears 1 and 2. Here, instead of calling as gear and pinion, they called as gear 1 and gear 2. That is 40 and 24. We can also make it capital T equal to 40, small t equal to 24. If the gear 2 rotates at 600 rpm, determine the velocity of sliding. Determine the velocity of the sliding when the contact is at the tip of the tooth of gear. Next, take addendum equal to 1 module. Also find the maximum velocity of sliding. So this is a question we have to solve. So how to start? Determine the velocity of the sliding. What is the formula for velocity of the sliding? The formula for velocity of the sliding equal to omega p plus sum of angular velocity of the pinion and angular velocity of the gear times, if it is end of the engagement, path of recess; if it is end of beginning of engagement, path of approach. Here they asked here, determine the velocity of sliding when the contact is at the tip of the tooth gear. Next, take addendum. What is the addendum? Addendum equal to, do 1 module. That addendum is Ra minus R equal to, that is called addendum. That equal to 1 module. That 1 module equal to a module pitch of 4 millimeter. So what is the module? That module equal to 4 millimeter. That is 4. Ra minus R equal to 4. That is the condition. Okay, and one more thing. And also if the gear 2 rotates, the gear 2 means pinion, that rotates, that is omega p, that is NP given. NP equal to 600 rpm. Then omega p equal to 2 pi np by 60. That is 2 pi times np, 600 by 60. That is 20 pi. Now we know omega p. What about omega g? How to calculate? Then from the gear ratio, g equal to 40 by 24. So we have to how to solve this problem? Yes, we have to start. Let us begin. Find the capital R and small ra and small letters ra and r. Then capital R equal to m into capital T by 2. We know that m, that is module 4 into 40 by 2. Similarly, ra equal to r plus m. Ra minus r equal to ra, that is also there. Now 84. Similarly, small r equal to m into small t by 2 and ra and radius of addendum circle and pitch circle radius. From this, ng by np or np by ng equal to capital T by small t. From that, ng we know the np, that is 600, small t is 24 and capital T 40. That is gear, speed of the gear wheel, ng. Now, here we have to calculate, determine the velocity of the sliding. From this, we want, what is that meaning? Here gear 1 means gear and gear 2 means pinion. So here pinion is the driver, then the tip of the driving wheel is in contact with the tooth of the driven wheel at the end of engagement. So we are calculating here what to be called velocity of the sliding when the contact velocity of sliding means it is the path of recess. The path of recess equal to Ra square minus R square cos square phi minus R sin phi. Then it is the velocity of sliding equal to omega p plus omega g times path of recess. Omega p we know 2 pi np by 60 or omega g 2 pi ng by 60, path of recess. Here we consider revolutions, radians per only. So that's why here 2 pi times np plus ng, not by second we are calculating. So if you want to make it directly, it comes per second. 2 pi times np plus ng by 60 into path of recess, that is 9.458. Then it comes 950.8 millimeter per second. Thus we can solve the objective 1 was solved here. So the thing is that here determine the velocity of the sliding when the contact is at the tip of the tooth of a gear. What is that meaning here? That the tip of the tooth gear takes place, gear 2. Here it is not point 2, it is the gear 2. Gear 2 is the pinion. So that on the pinion, when it will be taking place? When during the path of recess it takes place. That's why we considered velocity of sliding that equal to path of recess value. Velocity of sliding equal to omega p plus omega g times path of recess. Thus we calculated objective 1. So what is that objective 2? The objective 2 related to path of approach. What is that objective 2? Take addendum. Find the maximum velocity of sliding. The maximum velocity of sliding takes place during path of approach, not path of recess. At that time, the velocity of sliding, we need path of approach. The path of approach equal to RA square minus R square cos square phi. So it is capital R square. Okay. So the path of dimension to yes. So driving wheel, but here the point is that in the case of the gear wheel is the driver, the tip of the pinion. Again, it is coming to the back point of the pinion only. The path of approach also takes place, but views. Okay, that is the same. That is a 950.8 millimeters per second. So in this manner, we can solve the path of approach during what is the velocity of sliding when the contact is at the tip of the tooth gear 2, and also we found the maximum velocity of the sliding. So in this session we studied again path of contact, path of approach, arc of contact and contact ratio. Concepts we have studied through solving problems. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.